everyone. Today we are representing our applied project. Its name is Secure File Sharing System. So yeah, myself is Pardeep and she's
Aakanchhya, Amatya.
and he's
Manish, Shrestha.
yeah. So we'll walk through the project, like how the system works, who did what, and now she's gonna explain her part.
I'll be explaining the encryption, admin panel, and the sign up page.
And he
So I'll be walking you through the website and describe about the decryption part.
This is Aakanchhya. I'll cover how a new user registers. We collect first name, last name, email, and password. On the front end, validate, then send a JSON post to sign up. On the back end, we hash passwords with bcrypt and store them in SQLite. I'll just show you how we can sign up in this user interface. So it says, yep, sign up is successful, and then it goes to login page. I can show you the sign up HTML here. Front end uses fetch to post JSON. We keep the UI responsive and show success error or error messages. On success, we redirect to login. So in the database, we use a single SQLite database file meta.db. It's simple, file based, and perfect for the assignment scale. For the authorization of sign up, on the server, we normalize email, hash passwords, and bcrypt, and handle two common errors: duplicate email and database failures. Returning structured JSON makes the front end logic straightforward. So this is the admin page. Admins can sign in and view file records. I can show you how that's done. Logging successful. Then it takes us to the user file records. All the files that has been uploaded and encrypted get stored here. For the demo, we are using the hard-coded credentials. In production, we'd store our hashed admin password and sessions. So you can also download the link from here. For the code, I have sign up admin login HTML. This posts to admin login. On success, we redirect to dashboard. We surface errors in line. For the back end codes, we have a simple credential check. In a real deployment, we'd used hashed secrets, sessions, and role based access. Also, for backend, admin can fetch a list of uploaded files and their generated download plus key links, as I mentioned before. In the front end, the dashboard renders a clean table so admins can track uploads and test links. This is the encryption and upload page of Secure Vault's safe file sharing website. The user upload files on the upload and encrypt page. We post the files to upload and show a single download and decryption URL in one line. So this is how it's done. You have to press the choose file button, choose the file that you want to decrypt, open it. Upload and encrypt button needs to be clicked. Then it gives you the download and decryption URL link. Here you have the file ID plus the link. You can copy and send it to the receiver, or you can download and decrypt by yourself, and it gives you the file. It downloads and decrypts the file for you.
Hi everyone, myself Pradeep. So today I will be walking through the login process and the file encryption and the decryption, right? So basically, let's walk through the main folder. So this is our main folder. There we have all the files in there. So basically, in here we have two front end and back end folder, right? In the front end we have all the HTML and CSS. In the backend, we have server.js. That's the main file that runs on the server first. And then we have a package.js that has all the packages, dependencies, all the dependencies. So this is bcrypt is for the hashing, and then mulcha we have here, and then for the database we have here. So this is the chai and mocha is for the testing, right? So all the dependencies are here. And after that, I'm gonna go to the login page. So this is what our login.html looks like, right? So basically it's just overview. How does it look like? So the main file is authentication, like the authorization.js, right? So I will skip the sign up. So my main one is a login. So here it will ask for your email, your password, and then it sends the OTP on your email, right? So this is what it says in here. And even though we have used, I'll show you here. So we have one mailer.js, and then we have used node mailer in there to generate the password, like OTP. So basically that's my email, and that's the password from my email, right? So yeah, so this is the main file for the OTP, and then this is the dependencies, and then let's go to the main website. All right, okay, I have just opened it, but I will go to the login. All right, so this is what my login page looks like. So it just says in here, access your encryption file, add whether your doctor, teacher, and all of that, right? So okay, we're gonna log in here. Invalid OTP. See, so it's just valid for, because I have done it's 10 minutes before. So okay, we're gonna send the email again. Okay, because we have put the restrictions for it. So let's go and then have a login in here. Okay, so this is my email that I'm gonna use, and that's my password that I have used it. Okay, all right, so I have already signed up, and then I'm gonna check my email. I'm gonna get the OTP based on my email, right? So yeah, I got the OTP, and then I put it here. So 738822, that's what it looks like, right? So then my login is successful. So the main thing is here. All right, so I'm gonna explain you the encryption and the decryption. So this is what it looks like. So here we have to choose the file. Okay, I'll just get any screenshot. Okay, and then I'm gonna click the upload, and then we got the link. So we can just simply download it from here, or either you have a decryption file, right? If you have sent it to your friend. So basically you come here, and then you have to send this link to your friend when they're gonna download it, right? So basically what I'm gonna do, I'm gonna just copy this app, and then we're gonna go here. Okay, so I'm gonna put one here, and then I'm gonna paste it right here. So there you go. So basically, when if you want to send it, your friends can download it straight from here, and then either you can just send the download link. They can use the download link too, right? But the thing is, like, your file's gonna be encrypted. Either it's in the server or wherever it is. Okay, so you don't have to worry about it. Either it's like your thing gonna be stolen and everything, but everything is because in the authorization we have used this one, the bicrypt. This is for the hashing password. Either your whole secure file sharing system got hacked, but your file's not gonna be shown up because either they have encrypted and your passwords are encrypted too. All right, so we have upload.js. So in this one I'm gonna take you to the, so here we have used AES helpers in here. So basically we have used AES 256 characters in here, right? So this is kind of algorithm that we use. It's called Advanced Encryption Standard. So it is the one of the most secure and widely used method today, right? And then we have used the IV method too here. So it's kind of initialization vector. So that stored the files in the database and all of that, right? So we have put the expiry as well, and then yeah, so we can upload all the files as well that we have already in there. Okay, so we're gonna go through the download as well. So let's just go to download. So we have the same algorithm that we used in the other one as well. So we use the same thing in here too, other, and then it runs the one more thing. Let's just go through here. So this is all the things that happens in here, and then we have used the crypto.create.deci priv that's used for decryption of the key, right? So basically that once the file is decrypted, right? So the file gonna send it back to the server from where you can just simply download it up. Okay. So this is our main database file for it. Yep. That's all for my part. Thank you so much. And then the rest my teammates gonna explain it.
Now, I, Manish, would be explaining about the upload, encrypt, and download decrypt page that I've worked on. As an overview, the page looks like this. The page has got headers, two cards, and the footer. So basically, we have four main parts: the style CSS, the HTML structure, the upload and encrypt logic, and finally the download and decrypt logic. So this is the main code file. This is all the code that I've used in the page. To make it simpler, I have differentiated each part. Like this is style CSS. This is all the code for styling. This is all the HTML codes that I've used here, and upload and encrypt code, and lastly download and decrypt code. So let's walk through each. Let's see what style CSS has done in the page. The style CSS defines how the page looks. At the very top, we set variables like background colors, text colors, and brand colors so that the entire design stays consistent, like as you can see here. Then the body uses a dark gradient background, while the header and cards are styled with padding, rounded corners, and shadow to make them stand out. The buttons use a gradient from blue to green, and the small status badge called pills change color depending on whether something succeeded, failed, or is still waiting. Now, for the HTML part, this is the code, and let's see what it does. So HTML, at the top, there's a header with Secure World logo on the left, and at the right of it, there's two navigation links: upload and encrypt and download and decrypt. The main section inside has got two cards. The first card lets you choose a file encrypted and then show you a link you can share. The second card lets you paste the link, load the file's details, and decrypt it. There's also a footer at the bottom. Now, there's a main part coming. So this is upload and encrypt. This now we start the real action. So upload and encrypt logic. What's the logic behind it? When you click the button, the browser first generates a fresh AES-256 GCM key. This key will be used to encrypt the file because AES is fast and secure. Next, the browser generates an RSA OAEP key pair. The public key is used to lock or wrap the AES key, while the private key is exported so that it can be shared with the recipient. After that, the file itself is encrypted with AES GCM using a random initialization vector. The encrypted file together with the IV, the wrap key, and 1 hour expiry time. Finally, the code builds a special fragment link. Now, for the next part, this is download and decrypt logic. So what this does. In this page, download and decrypt, when you paste the link and click load, the page extracts the ID and the private key from it. It then looks up and stored object in local storage. If the file has expired, it shows an error. If not, it displays the file name, size, and how much time is left before it expires. Next, the private RSA key is imported into the browser. This key is used to unwrap the AES key from the wrapped data. Once the AES key is recovered, it is used to decrypt the ciphertext with AES GCM and original IV. Finally, the decrypted data is turned back into the file using a blob, and browser automatically downloads it with the original file name. Now I would like to show you a demo how you can use it. So this is the page. So you choose a file. You can select the file. So I choose this one. So we have already chosen here. Now we click encrypt and create a link. So this one was done. Share the fragments on below. So this is what we need. This is the link that we can share to our friends or whoever we want. So we copy link and we can share it. Otherwise, if you want to download, just for the example, I'll show you here. I'll paste it. I pasted it. Then we click load link. So link OK, ready to decrypt. So now if you click download and decrypt, let's see here. It's already downloaded, and this is how it goes. So when you send the link to your friends, you can share the link. Then whoever is receiving it, they can directly copy the link, paste it in the download and decrypt section, load the link, and then download it. And finally, they can receive it. This way, my upload and encrypt and download and encrypt page is working. So this is the RS algorithm that I've used here for encryption and decryption. But in the actual website that we have created, we have used AES algorithm for encryption and decryption. The main reasons behind using it are: 1. Encrypting and decrypting with RSA is much slower compared to symmetric algorithm like AES. Second, RSA is rarely used to encrypt large data directly. Instead, it usually encrypts only a session key, which then encrypts the bulk data using AES. And lastly, to maintain strong security, RSA requires very large keys. Example 2048 bits or 4096 bits. And that is all for this project. Thank you. Have a nice day.